Have you ever looked at an expression like x squared plus 5x plus 6 and wondered how to break it down into simpler parts? Many students struggle with this, but today you'll discover the powerful technique of factoring trinomials that will transform how you approach algebra. Welcome to this comprehensive guide on factorable trinomials. In this video, you'll master the essential skill of breaking down three-term polynomial expressions into their simplest factors. This fundamental technique is crucial for solving quadratic equations and simplifying complex algebraic expressions. A trinomial is a polynomial expression that contains exactly three terms. The standard form of a trinomial is a x squared plus bx plus c, where a, b, and c are constants called coefficients, and x is our variable. Let's break down each component. The coefficient a is the number in front of x squared, b is the coefficient of x, and c is the constant term with no variable attached. Here are some concrete examples of trinomials. Notice how each expression has exactly three terms with different coefficients and constants. Now, what does it mean to factor a trinomial? Factoring is the process of expressing a trinomial as a product of two binomials. This is essentially the reverse operation of expanding two binomials using the FOIL method. This factoring process is incredibly useful in algebra. It allows us to solve quadratic equations by setting each factor equal to 0, simplify complex expressions, and better understand the structure of polynomial functions. Mastering this skill will make many advanced algebra topics much more manageable. Before we can factor trinomials, we need to understand exactly what they are. A trinomial is a polynomial expression that contains exactly three terms. The general form of a trinomial is a x squared plus bx plus c, where a, b, and c are constants and x is the variable. Let me show you some specific examples. Here's x squared plus 5x plus 6. This is a trinomial because it has three terms, x squared, 5x, and 6. Here's another example, 2x squared minus 3x plus 1. Again, we have exactly three terms, making this a trinomial. Now that we understand what trinomials are, let's explore what factoring means. Factoring is the process of breaking down a trinomial into two binomials that, when multiplied together, give you back the original trinomial. For example, if we factor x squared plus 5x plus 6, we get the product of x plus 2 times x plus 3. To understand factoring better, we need to review the FOIL method. FOIL stands for first, outer, inner, last, and it's how we multiply two binomials together. Let me demonstrate FOIL using x plus 2 times x plus 3. First, we multiply the first terms, x times x equals x squared. Next, the outer terms, x times 3 equals 3x. Then the inner terms, 2 times x equals 2x. Finally, the last terms, 2 times 3 equals 6. When we combine all these terms, we get x squared plus 3x plus 2x plus 6, which simplifies to x squared plus 5x plus 6. Factoring is simply the reverse of this FOIL process. Instead of starting with two binomials and getting a trinomial, we start with a trinomial and find the two binomials. Before we start factoring any trinomial, there's an important first step we must always check: the greatest common factor, or GCF. For example, consider the trinomial 6x squared plus 12x plus 18. Notice that all three terms are divisible by 6. We factor out the 6 first, giving us 6 times the quantity x squared plus 2x plus 3. This simplifies our work significantly. Always check for a GCF first, because it makes the remaining trinomial simpler to factor. This is a crucial step that many students forget, but it can save you time and reduce errors. Now that we understand what trinomials are, what factoring means, and the importance of checking for a GCF first, we're ready to learn specific methods for factoring trinomials. The trial and error method, also known as the guess and check method, is one of the most intuitive approaches to factoring trinomials. This method works particularly well when the leading coefficient is 1. This method is best suited for trinomials where the leading coefficient, the coefficient of x squared, equals 1. The general form looks like x squared plus bx plus c, where b and c are constants. The core concept is simple. We need to find two numbers, let's call them m and n, that satisfy two conditions simultaneously. First, these two numbers must add up to b, the coefficient of the middle term. Second, these same two numbers must multiply to give us c, the constant term. Once we find these two numbers, we can write the trinomial as the product of two binomials, x plus m times x plus n. Let's work through our first example, x squared plus 7x plus 12. we need to identify the values of b and c. Here, b equals 7 and c equals 12. Now we need two numbers that add to 7 and multiply to 12. Let's systematically list the factor pairs of 12. We have 1 times 12, 2 times 6, and 3 times 4. Now we check which pair adds up to 7. 1 plus 12 equals 13, 2 plus 6 equals 8, 3 plus 4 equals 7. Perfect. So our two numbers are 3 and 4. Therefore, x squared plus 7x plus 12 factors is x plus 3 times x plus 4. We should always verify our answer by expanding the factored form using the FOIL method. Let's try another example, x squared plus 5x plus 6. Again, we identify b equals 5 and c equals 6. The factor pairs of 6 are 1 times 6 and 2 times 3. Now we check which pair adds to 5. 1 plus 6 equals 7, which is too big. 2 plus 3 equals 5, which is exactly what we need. Therefore, x squared plus 5x plus 6 factors as x plus 2 times x plus 3. Here are the key strategy tips for the trial and error method. First, systematically list all factor pairs of the constant term c. Second, check which pair adds up to the coefficient b. Third, write the factored form using those two numbers. Finally, always verify your answer by expanding back to the original trinomial. Be careful to avoid these common mistakes. Don't forget to check that your numbers actually add up to b. Also, make sure you consider all possible factor pairs of c, not just the first ones you think of. The trial and error method is intuitive and effective for trinomials with a leading coefficient of 1. With practice, you'll develop the ability to quickly identify the correct factor pairs and solve these problems efficiently. The AC method is particularly useful when we're dealing with trinomials where the leading coefficient, that's the coefficient of x squared, is not equal to 1. This method is also called factoring by grouping. The AC method follows 5 clear steps. First, we multiply the coefficients a and c. Second, we find two numbers that multiply to give us AC and add to give us b. Third, we rewrite the middle term using these two numbers. Fourth, we factor by grouping the first two terms and the last two terms. Finally, we factor out the common binomial factor. Now let's work through a complete example. We want to factor the trinomial 6x squared plus 11x plus 4. Notice that the leading coefficient is 6, which is not equal to 1, so the AC method is perfect for this problem. Step 1, we identify our coefficients. Here a equals 6, b equals 11, and c equals 4. Now we multiply a times c. 6 times 4 equals 24, so AC equals 24. Step 2, we need to find two numbers. Let's call them m and n, such that m times n equals 24 and m plus n equals 11. Let's check the factor pairs of 24. 1 times 24 gives us 24, but 1 plus 24 equals 25, not 11. 2 times 12 gives us 24, but 2 plus 12 equals 14. 3 times 8 gives us 24, and 3 plus 8 equals 11. Perfect. 4 times 6 gives us 24, but 4 plus 6 equals 10. So our two numbers are 3 and 8, since they multiply to 24 and add to 11. Step 3. Now we rewrite our original trinomial by splitting the middle term 11x into 8x plus 3x. This gives us 6x squared plus 8x plus 3x plus 4. Step 4. We group the first two terms and the last two terms. From the first group, 6x squared plus 8x, we can factor out 2x, giving us 2x times the quantity 3x plus 4. From the second group, 3x plus 4, we factor out 1, giving us 1 times the quantity 3x plus 4. Step 5. Notice that both terms have the common binomial factor 3x plus 4. We can factor this out, giving us the quantity 2x plus 1 times the quantity 3x plus 4. This is our final factored form. We can verify our answer by expanding. 2x plus 1 times 3x plus 4 gives us 6x squared plus 8x plus 3x plus 4, which simplifies to 6x squared plus 11x plus 4. This matches our original trinomial, confirming our factorization is correct. The AC method works because it systematically breaks down the middle term in a way that allows us to group terms and factor out common factors. This method is particularly powerful for trinomials with leading coefficients other than 1, where trial and error might be more time-consuming. Now let's work through our first example step by step. we'll factor the trinomial x squared plus 5x plus 6 using the trial and error method. Here's our trinomial x squared plus 5x plus 6. Our goal is to express this as a product of two binomials. For the trial and error method, we need to find two numbers that satisfy two conditions. First, they must multiply together to give us 6, which is our constant term. Second, they must add together to give us 5, which is the coefficient of our middle term. Let's systematically check the factor pairs of 6. First, we have 1 times 6 equals 6. But 1 plus 6 equals 7, not 5, so this doesn't work. Next, we try 2 times 3 equals 6, and 2 plus 3 equals 5. Perfect, this is exactly what we need. Since 2 and 3 are our magic numbers, we can write our factored form as x squared plus 5x plus 6 equals the quantity x plus 2 times the quantity x plus 3. Now let's verify our answer by expanding the factored form using the FOIL method. FOIL stands for first, outer, inner, last. First, we multiply the first terms. X times x equals x squared. Outer means we multiply the outer terms. X times 3 equals 3x. Inner means we multiply the inner terms. 2 times x equals 2x. Last, we multiply the last terms. 2 times 3 equals 6. Now we combine all the terms we found, x squared plus 3x plus 2x plus 6. We can combine the like terms 3x and 2x to get 5x. This simplifies to x squared plus 5x plus 6, which is exactly our original trinomial. This confirms that our factorization is correct. So our final answer is x squared plus 5x plus 6 equals the quantity x plus 2 times the quantity x plus 3. This example shows how the trial and error method works systematically to find the correct factors. Now we'll tackle a more challenging example where the leading coefficient is not equal to 1. We need to factor 2x squared plus 7x plus 3 using the AC method. First, let's identify our coefficients. We have a equals 2, b equals 7, and c equals 3. Notice that since a is not equal to 1, this will require the full AC method. Step 1, we multiply a times c. That's 2 times 3, which equals 6. This product will help us find the two numbers we need for factoring. Step 2, we need to find two numbers that multiply to 6 and add to 7. Let's think systematically about the factors of 6. The factors of 6 are 1 times 6 equals 6 and 2 times 3 equals 6. Now we check which pair adds up to 7. 1 plus 6 equals 7. That's exactly what we need. So our two numbers are 6 and 1. Step 3. We rewrite the middle term 7x as 6x plus 1x. This splits our trinomial into 4 terms, setting us up for factoring by grouping. Step 4. We group the terms in pairs. The first group contains 2x squared plus 6x, and the second group contains 1x plus 3. Step 5. We factor out the greatest common factor from each group. From the first group, we factor out 2x, giving us 2x times the quantity x plus 3. From the second group, we factor out 1, giving us 1 times the quantity x plus 3. Step 6. Notice that both terms have the common binomial factor x plus 3. We can factor this out, leaving us with the final answer, 2x plus 1 times x plus 3. Now let's verify our answer by expanding 2x plus 1 times x plus 3 using the FOIL method. First terms, 2x times x equals 2x squared. Outer terms, 2x times 3 equals 6x. Inner terms, 1 times x equals x. Last terms, 1 times 3 equals 3. When we combine like terms, we get 2x squared plus 6x plus x plus 3, which simplifies to 2x squared plus 7x plus 3. This matches our original trinomial perfectly, confirming our factorization is correct. Therefore, 2x squared plus 7x plus 3 factors to 2x plus 1 times x plus 3. This example demonstrates how the AC method handles trinomials with leading coefficients other than 1. Now we're going to explore a special type of trinomial that can make factoring much easier once you recognize the pattern. These are called perfect square trinomials. A perfect square trinomial is a special trinomial that results from squaring a binomial expression. When we square a binomial like x plus 3, we get a trinomial that follows a very specific pattern. When we square x plus 3, we're multiplying x plus 3 by itself. Using FOIL, we get x squared plus 3x plus 3x plus 9, which simplifies to x squared plus 6x plus 9. Perfect square trinomials follow two main patterns. Pattern 1 has a positive middle term. A squared plus 2ab plus b squared equals a plus b quantity squared. Pattern 2 has a negative middle term, a squared minus 2ab plus b squared equals a minus b quantity squared. To recognize a perfect square trinomial, check two things. First, the first and last terms must be perfect squares. Second, the middle term must equal 2 times the square root of the first term times the square root of the last term. For our first example, we need to factor 4x squared plus 12x plus 9. We'll check if this is a perfect square trinomial. Step 1, we check if the first and last terms are perfect squares. 4x squared equals 2x quantity squared, and 9 equals 3 squared. Both are perfect squares. Step 2, we check if the middle term equals 2ab. Here, a equals 2x and b equals 3. So 2 times 2x times 3 equals 12x, which matches our middle term. Since both conditions are met, this is a perfect square trinomial. Therefore, 4x squared plus 12x plus 9 factors as 2x plus 3 quantity squared. For our second example, we'll factor x squared minus 6x plus 9. Notice this has a negative middle term, so we'll use the second pattern. Step 1. X squared is already a perfect square, and 9 equals 3 squared. Both terms are perfect squares. Step 2. For the negative pattern, we check if the middle term equals negative 2ab. Here, negative 2 times x times 3 equals negative 6x, which matches our middle term. This follows the negative pattern, so x squared minus 6x plus 9 factors as x minus 3 quantity squared. For our final example, we'll factor 9x squared plus 24x plus 16. This is slightly more complex, but we'll use the same process. Step 1, 9x squared equals 3x quantity squared, and 16 equals 4 squared. Both are perfect squares. Step 2, we verify the middle term. 2 times 3x times 4 equals 24x, which matches our middle term perfectly. This confirms it's a perfect square trinomial. Therefore, 9x squared plus 24x plus 16 factors as 3x plus 4 quantity squared. The key takeaway is that recognizing perfect square trinomial patterns can save you significant time. Always verify both conditions, that the first and last terms are perfect squares, and that the middle term follows the 2ab pattern. Remember these two essential patterns for future factoring problems. Now that we've covered the main methods for factoring trinomials, let's discuss some essential tips, common mistakes to avoid, and wrap up everything we've learned. First, here are some essential tips that will help you become more successful at factoring trinomials. Tip number 1. Always look for the greatest common factor first. This can significantly simplify your work. For example, with 6x squared plus 18x plus 12, we first factor out the GCF of 6, giving us 6 times the quantity x squared plus 3x plus 2, which then factors to 6 times the quantity x plus 1 times the quantity x plus 2. Tip number 2. Always verify your answer by expanding your factored form back to the original trinomial. Now, let's look at some common mistakes students make when factoring trinomials and how to avoid them. Mistake number 1 is sign errors. For x squared minus 5x plus 6, students often write x plus 2 times x plus 3, but this is wrong. The correct factorization is x minus 2 times x minus 3 because we need two numbers that multiply to positive 6 and add to negative 5. Mistake number 2 is forgetting to factor out the greatest common factor first. For 2x squared plus 8x plus 6, students might write 2x plus 2 times x plus 3, but this is incomplete. The complete factorization is 2 times the quantity x plus 1 times the quantity x plus 3. One of the most important habits you can develop is always verifying your factored form by expanding it back to the original trinomial. For example, if we factored x squared plus 7x plus 12 as x plus 3 times x plus 4, we should expand this to verify. Using FOIL, x times x gives x squared, x times 4 gives 4x, 3 times x gives 3x, and 3 times 4 gives 12. Combining like terms, x squared plus 4x plus 3x plus 12 equals x squared plus 7x plus 12. This matches our original trinomial, so our factorization is correct. Sometimes you'll encounter trinomials that cannot be factored using integers. In these cases, you can use the quadratic formula to find the roots. For example, x squared plus 3x plus 1 cannot be factored with integer coefficients. In this case, we would use the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac, all over 2a. Let's recap the key takeaways from our study of factoring trinomials. First, always look for the greatest common factor. Second, use trial and error for simple cases. Third, use the AC method for more complex trinomials. Fourth, watch out for sign errors. Fifth, always verify your answer by expanding. And finally, use the quadratic formula when factoring with integers isn't possible. Factoring trinomials is a crucial skill in algebra, and with practice, you'll become more proficient at it. Thanks for watching. Don't forget to like this video, leave a comment if you have questions, and subscribe for more math tutorials. Keep practicing, and you'll master factoring trinomials in no time.